is, we set up a notification where if one panel is not as accurate as the other, shows up, so we call the consumer, hey, go and check this out, what's going on. Some panels, like the ones I have, every single cell is placed in series. So if one panel is shadowed, that automatically makes an open, and the whole panel won't produce anything. So yes, a bird poop may possibly damage your whole thing. My audiences would be students. I think this would be good for students to take it to the next level. If this time the senior design was cut a little short. If I had another week, I would have connected to MATLAB and figured out a way to create the data tables. The way I created my graphs, I copied the data and I went into Excel and I made the graphs myself. But with a little more time, I would have gone on MATLAB, created a code so that it could generate it on its own per day. Students could also use it just to learn how to use Raspberry Pi or for a database connection, or learn how to do the ADC. Constraints, reliability. The Raspberry Pi again is sensitive device, so getting a casing for it would be ideal to protect it from any other static that may be in the area that could damage the processor, or just to keep it safe, something land in it or it drops. Other than that, it's pretty robust. Efficiency. The Raspberry Pi works at 700 megahertz. In relation to the HCS12, which is only 8 megahertz, this is way faster. And if I was to connect to a database with the HCS12, it was going to be almost impossible because I have to go through serial connection to the computer to then say the database, when the Raspberry Pi has Ethernet connection on it already. Cost and time. Project cost me about $50, and now that it's designed, it will be very easy to mass produce many more. The Raspberry Pi again cost $35, and the ADC chip was like $3, and then the shipping and handling, that's what took it to $50. Maintainability, 4 gigabytes. So if you see right here, the Raspberry Pi needs to have an SD card in it. That's where the operating system is working from. That's a 4 gigabyte. With 4 gigabytes, you could store data in there for 9, 10 years. So if you wanted to go on more than that, you could get a 16 gigabyte or 8 gigabyte, and pretty set for life. It's environmentally friendly. Solar technology, again, is part of the Going Green movement. It has no adverse effect in the environment. So this is an environmentally friendly project, and it's very safe to operate. I wouldn't think a person, in their homes could do it on their own. It would be part of a company for them to do it, unless, we take it to the point where it comes packaged with multiple channels for anybody to just hook on. But then again, I don't think many people would actually understand that. So safe to operate, they might damage it. I would say let the companies handle that, people who install the panels. In conclusion, this product is very useful, one, for many different purposes. At the same time, it records data values, it stores charges, empowers the business at home. The data may be used to study sun energy throughout the day, a week, a month, or a year. It will make the money spent on penalty back within a shorter time. And it also allows the consumer to not have to worry about their panels and how they're performing. At the end, the consumer's solar panels will never be wasting time, ideally, because you will always be getting as much as efficiency as possible from your panels. And every bit of sunlight of the day that it comes with, it will be working. Special thanks to Dr. Damu for pushing me. Aaron, boss. Professor Michael Otis, he's not here. He helped me out with the panels. Thanks to Tom. Tom, I didn't write you on here, but you know, I was thinking about you. I had you in mind. I just forgot to write you down here. The engineering department for also making this possible and giving me the funds. And the guys in room 208. So thank you all. Any questions?
So what do you store the data? You can store it on the internet somewhere or on the scan disk card over?
Yes, you know,
Both, or
the scan disk is what sends the data to the database server.
Oh.
But it actually is stored in the scan disk,
Yeah.
and the scan disk sends it over to the database. I have a short video.
You have to drag it across.
Come over here for a second.
That mouse is awful, so you have to really press down hard. So which one, Jason?
I have a video that I want to show. Okay, so let me show you.
Oh, there you go. You almost got it. Normal size. Where is that's normal size, really? There we go.
So I showed you the data tables of the database, and now this is the actual charge controlling, a small video. So right now, pause it real quick, so I can explain what it is. So I didn't use a solar panel because one of my batteries blew out, so I'm just showing you for the purpose of if the voltage is low, then it won't charge the battery, but once it reaches that peak, then it goes in and charges it. So right now we were at 0 volts, these are the batteries, and a plate. So the batteries, the display reads not charging. So now you're gonna go ahead and turn it up. So once it reaches about 21.5 volts, it starts charging. Display indicates it. And about every 10 seconds, it changes over. So the switch over there goes off so that it can check the battery voltage. Once it checks the battery voltage, if the battery voltage is fully charged, then it stops charging it. If it's not, then it continues to charge. That's my bad. Yes?
What happened to your batteries before? Something happened to your batteries in the middle of the project. What was that again?
One of them blew out. Shorted it.
What did you do to fix it?
Oh. I blew out all 4 batteries. I blew out all 4 batteries, and these are lead acid batteries. So I blew all 4 of them out, and I was freaking out because I thought I didn't know what I was going to do. But these batteries, they came empty, and I had to pour the acid in them to make them work. So when they blew out, I had some acid left. So I poured that acid out. It was dangerous. I poured the acid out, and I refilled it with the rest of the acid that was left. So I only had enough for 3. So that's why I had 3 batteries and not 4. The 4th one, I didn't have enough acid. So
The constraint that you have, constraints, you can't create your own constraints. These are ABIT-defined constraints. So there are set constraints you could go. You created some which are not. You know which one I'm talking about?
yes.
Okay, so
I
those
thought- I
are,
thought.
they're on their list of the ones, there's a specific list.
Okay.
You should.
Yeah, I looked for the constraints. Those were the ones, but I didn't go to their website. I just looked for constraints.
Well, we have it
That's why.
on it is on the,
It's in the handout.
in the handouts.
They put together.
There are about 7 of them, you need to take use at least 4 of them. If you have others that you wanna add to it, you can do that, but you need to use at least 4 of the
Those.
constraints that are listed.
I took TechCom a while back, so.
All right.
Now I know, thank you. Any more questions?